except this time it's almost like you're subtracting them from each other. Now, I give you a bit of a strange one here. Let's deal with the a to the fifth over a to the third. Think of it again like you're subtracting it. So 5 minus 3 is 2. So this will end up having an a to the power of 2. Now, the b's are a bit strange. It's like a negative exponent. Now, here's a quick thing. If you have negative exponents, for example, this one's in the top, technically you can move it to the bottom. So you can move to the b to the first power to the bottom. Likewise, if this was a negative 3 on the bottom, it can move the top. They essentially switch sides, just like how negative is the opposite of a positive and it's the opposite sign. They technically belong on the other side, but let's ignore that for a second. So think of it as negative 1 minus 3. Well, negative 1 minus 3 is a negative 4. Okay, so you can think of that as b to the negative fourth. Now, technically speaking, this 8 over 16, you can get a decimal, but let's leave it like a fraction. 8/16 simplifies down to 1/2. You really don't need this 1 right here because you have these other terms on top. Now, there's nothing wrong with this. However, I oftentimes like to simplify this down a little further. Again, remember how I said negative exponents kind of want to go to the other side. See how this negative exponent is on the top? Well, I like to rewrite it as it being on the bottom in the denominator. So I like to write it as b to the fourth in the denominator with a little 2 down there and my a to the second. To me, this looks slightly cleaner, but guess what? They're exactly the same thing. This just looks a little nicer to me. That's what happens when you divide things with exponents. Basically, you're subtracting them.